3, 2, 1, go, and we're live. This is Retraice segment number 91 for Thursday, December 22nd, the second in a doubleheader. It's Thursday, December 22nd, 2022, and this is the second 222022. That's a palindrome, right? All right, 11 p.m. Eastern, 8 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. We're going to control some computers. Re92, if you want to know about that. Long answer, natural artificial. I did it in the last one. Go check out the first in the doubleheader. You're also going to need to look at that one if you want to land the plane, figure out where we're at in this best first search journey. This search for the best first search. That's where we're at. That's what we're doing. What does it look like? Doesn't look like that. It looks like getting from A to B. Getting from A to B looks like, now let's see if I can find this. I don't know, AIMA? No, it's notes. We're going full speed ahead, people. I hate that. That does that all the time. We're going full speed ahead here, people. No time for nonsense. We're getting from A to B. And we want to do it with a computer and not our brains. The source code that we're working from is on AIMA, the official AIMA Python GitHub, and you can get to our source code. We've done a lot of notes. That's what all this stuff is. Have fun looking through that. But this is our point of departure. What does it mean? Well, where we left off in Re90, we were here, and I was just talking about how once we've formally defined a problem and instantiated it as T problem, and we feel like we're ready to execute our best first search implementation here, which we haven't worked through. We're just sort of, this whole thing needs some attention from us. But really, the thing we have one more dependency, and it's this F and this priority queue. So let's just see what it looks like to make an attempt here. So let's load our file. And let's remember what we did. T problem is not there. Okay, so let's, yeah, that's what I want to use. So I'll grab the, whoops, not too much. That's all I need. So I don't even have to type this. It's probably in IPython's memory. Is it? T problem is not. Okay, so we had to grab it. Okay, so here what we're doing here is comparable to what the AIMA people here are doing at the bottom. Their route problem 0 is an instantiation of the class route problem with an initial state of A and a goal state of A. Kind of a pickle they got themselves in there, haven't they? The map that they're using, the state space, which is the states, and the actions is this map here, and then they iterate on that. Route problem 2 for them, you get from A to B. That's kind of like what we're doing, okay? Route problem 3 and to L, and then E and T, blah, blah, blah. Okay, so T problem, we're doing this one, and we're using these toy inputs, test inputs or toy inputs. Actually, I've got to, we have to update our notes, run and Re91. Okay, so to instantiate our problem, we gave it the T-links, which is the actions available in the state space, and the other argument that the other dictionary argument that we gave was the states in the state. Oh, I found a flaw in my little plan here. I didn't give coordinates for. Wow, I wonder if that's what was causing me the problem. Okay, well, I might as well fix this before we instantiate this problem. So I added I don't have coordinates for yo mama. Gosh. Okay. Yo mama and dada are the ones I need to add to my locations dictionary. I didn't even realize. Okay. So yo is, let's say, oh, come on. I don't know. Where's yo? This is going to be crazy. Let's say yo is at 60, 30. Nice and clean. Let's say mama is at, let's make it an ugly number. 87 and 17. Okay, how about that? And then let's say, that's not right. That's not the right syntax. 87 and 7. What did I say? 17? They're not ugly. Those are beautiful numbers, actually, from a mathematical point of view. Always love a prime. 17. Is 17 prime? Okay. It's prime. I'm not a good mathematical disclaimer. I'm not a good programmer. Programming disclaimer. I am not a good mathematician. All right. And then what's the last one? Dada. We're going to say. Where's data going to be? Data is going to be somewhere nice and orderly. 40. I don't know if this is it shouldn't cause issues, right? Like, it's just an arbitrary space. They don't actually have to. We're going to find out. We're going to find out real quick. No, they can be anywhere, but the distances aren't going to make sense. Because those distances, I don't know. Let's just see what happens. Otherwise, we're going to have to get rid of the yo mom and data. And that sounds like a terrible thing. Okay, so now we're instantiating. Let me just check my syntax here. Yo, colon, parentheses, comma, mama, colon, parentheses, comma. There's no space on the front of that. Is that going to be an issue? Of course it is. If I think it's not going to be, then it will be. Okay. Comma, colon, and oftentimes at the end of the dictionary there's a comma. No, there's no. Yeah, that's fine. I don't give a shit. Just doing. There's no one up here, but this one's already worked. So I'm just gonna break things here. This is what's gonna end our free time. Is crap like this. We're gonna make some little syntax error. Whoops, syntax error. Okay, let's instantiate our problem. We want to get from A to dada in the map T map. Has T map been instantiated? No. So let's not do that. T map equals T locations. That's the T map we want. T links and T locations. Okay, now what? I've already forgotten. Toy problem. Really? I thought it's in my clipboard. Okay. T problem equals, it's an instantiation of route problem with the arguments getting from initial state A to final state dada, and the map equals T map. Let's see what happens. Let's see if it doesn't throw any errors. Good. Now, we've got a problem in memory. What do we do next? Well, we go over to best first search, okay? And we're going to give best first search an argument. And I know this isn't going to work, or maybe it'll work because, darn it. You could do better. I could do better. There we go. And our problem is going to be T problem. And our F value, I just said 10 before. I know this is going to cause me trouble on this frontier, okay? I know this. I'm doing this. This is not wrong, but I was hoping it would just be an integer. Or maybe I'm doing something wrong in the way that I'm entering it. Anyway. Okay, yeah, okay. So here, let's see the errors that we get. So we try to use the function best first search, which is our implementation of the best first search algorithm, and we pass it the argument T problem and the value for F of 10, and we get int object is not callable. That's what I got before. So it had nothing to do with the coordinates in my T locations, but it was good to fix those anyway. I have no idea. I've read about this, and it's supposed to be a beginner error. Shocking that your favorite podcaster who does not know how to program is committing beginner errors in his program. Shocking. And I fiddled around with it, but it wasn't an obvious thing for me. So what I think, I don't know if I'm being clear here. This is our error. All this stuff above it is just extra information. It seems to happen at line 71. Why does it say 86? What's on 86? What the heck is... there's no 86. No, that is... 86 is... No, this is 86 is something else. What? 71. Oh, yeah, pair. Okay, pair equals self.key is go to line 71. Oh, 71. Self.items.pair. I'm not sure if these line numbers correspond. They do not. Do they? What are we doing up here? This is the priority queue. This is where we're having trouble. Sorry, I haven't done this. I haven't really scrutinized this error message yet. 67. Let's see if that's self.add.item. 67. No. Very close though. What are we? Okay, so let's read it from the top and bottom. Best first search problem argument T problem argument T, or argument T problem argument 10, and in the function best first search, priority queue is 86. Okay, that's here. Ooh, here, not really there, but you know that neck of the woods. 86, and our priority queue is, it's like off by 1. Why is it off by 1? The line numbers. I don't know why that would be. Reached problem initial node, yeah, and node equals problem initial, yeah. Okay, so it's like off by 1. I don't. That's nothing to sneeze at. I mean, that's an indication of something. But we're learning. Okay. And these are in reverse order. These errors, or these indicators, these hints, these trace. I guess this is a traceback. I don't know what a traceback is, other than it happens when it's data thrown at you when you have an error in your program. So, I mean, I'm this is the problem to me. The int object is not callable. However we're supposed to fix that. Okay. What did I read today? Is it here? Actually, I'll just copy the. This and this. Int object is not callable error occurs when you declare a variable and name it with a built-in function, such as int sum max. Now there's the error also. Okay, so I declared a variable and I named it with a built-in, probably int. I mean, I think I know. Is it a keyword argument? Okay. No, I can't get excited. It's never what I think. Whenever I do that, it's, stop it. It's never what I think. So it's not going to be that. No, it's not keyword. It's not, because I gave it, whoops. Oh, geez, that's on read only. I was hoping that this would have to be a keyword argument, but it's not. Okay, so how should it's not going to be like a string, right? String is not callable. What is it? How am I supposed to? I mean, I'm just picking a random number there because it's supposed to sort. Okay, problem not to search nodes with a minimum f of node value first. Right. F is a function that I haven't defined. Okay. What's the node gonna look? Okay, it's just. Oh, okay. How about this? Let's define a function f. Def f takes the argument of t value, and it's going to do what to it? It's just I haven't written a lot of functions in my life. Return t value. Let's just make this simple. Right? Is my indentation there good? Just do it. Okay, now let's try it. That? Oh! Holy shit. Holy fucking shit, I did it, dude. I think that's correct. All right. No, it's got to return more information. I'm sorry, but it wasn't an error, man. I can get excited if it's not an error, and I do some. I'm not a programmer, so when things work or do something that looks intentional, I get excited. You can't fault me for that. Why is it returning the? I don't know what that means. I don't know what if it. What did I give it? I gave it a problem. I gave it our T problem. Okay, so let's go look at T problem. T problem is this one. Let's move it out a little bit here. And we get from A to dada. It just returned dada. It didn't give us like the it's oops. Yeah, no, that's good. I don't know what the hell just happened. Just that's too easy. Like it's just returning. It's not returning failure. So what is it doing? It's setting the first node equal to the problem initial state. It's a node of the problem initial state. Can we just do a little easy one here? Okay. So node, no. Oh no, don't do that. Oh no. Don't do that. I keep forgetting. It's because it's not you Vim users will love that I keep accidentally forgetting to put on read only because you guys don't have that problem. But maybe that'll be me someday. Maybe someday I'll be a Vim user. That would be so cool. What am I searching for? Class node. There. And let's unpack it. So there's not much going on here. You initialize, you get a parent, you grab a parent. Well, from a state, the node, if we're creating a node, our first argument is the state, the second one's the parent, third one is the action, and then the path cost is equal to 0. But maybe I shouldn't do that. Oh, I don't know. This is going to take some experimenting. X5, other. But anyway, best first search is taking my problem and my F function that's just returning a T value. I wonder if I just put, instead of T value, instead of taking an argument, it takes no argument. Because you know what? So, okay. I don't know if I can find this. Where is this written down? Looking at the book. Yeah, so different, yeah. Page 73. By employing different F functions, F of, these are our evaluation functions, we get different specific algorithms. What does that mean? I shall show you kind of what that means. What are we doing here? AIMA, no. Source, what is it? Oh gosh, I don't know what to get. No. AIMA, is it the, yeah, that. Boom. Okay, so we have, when they say using different F functions gets you different algorithms, they're saying that they're talking about, I think they're talking about yeah, here. So actually, let's go up a little bit. Okay, so our best first search, this is the one we're fiddling with. Best first search with various f of n functions gives us different search algorithms. Note that A star, weighted A star, and greedy search can be given a heuristic. That's informed search. We're not doing that right now. But if H is not supplied, they use the problem's default H function. If the problem does not define one, it is taken as H of n equals 0. Okay, so this is the one we're working on. Can you see that? Okay, good. Can you hear me? Good. Okay. We've had problems with both of those things recently. It drives me crazy. Best first tree search, I don't know anything about that because we're not working on that right now, is a different implementation, different procedure. So search. Yeah, I was expecting to see definitions of F here. Oh, I see definitions of F. Okay. Not in our first one, but they're so low down. Look. So like if we look at A star, F is a lambda function, N is the argument, and G of N plus H of N. H is H or, it's a heuristic. G of N is the cost function, I think. Search nodes with minimum f of n equals G of N. Okay. Then F equals lambda again. Gosh, that's the same. A star tree search. Oh, A star search versus A star tree search. Can you see my cursor? Yeah. Okay. So okay, but we're changing. Well, we're not really changing the F function there, but we're changing the procedure between these two. But they both have a lambda G of N plus H of N. Weighted A star, H equals none, weight equals 1.4, F equals lambda, you multiply the weight times the heuristic, the heuristic times the weight, and then the cost function there, G of N. Greedy best first search has F equals H. Uniform cost search, F equals G, yeah, because G is the cost function. Although I don't see where it's like defined. Doesn't matter. Breadth first, F equals length of and so you return a length of the node. No, a length of the what? I don't know, but anyway. And then depth first search. Depth first, breadth first search is that. Okay. So when we talk about different f of n functions, we have them in those, but in best first search, we're searching for, we're prioritizing nodes with a minimum f of node value first. Now, I don't want the f of node to be, what's the, let's see, what properties do we have of node? Attributes. Node has a, representation there. Less than a length. There's nothing there that I can obviously use. I don't know. But that is where to go next. That's what we're gonna have to sort out, is this I'm going to kill OBS. I'm going to kill it. Oh, I was already there. Actually, it's not OBS's fault. User error. We're going to have to sort out our error message, but also, like, when I define f, the f function here, we got to figure out what the hell this means, that it returns dada. Because what we want, like, our solution shouldn't just be a... Wait a second. My problem goes from A to data. A to data is not directly connected, is it? Let's do t problem dot neighbors. Is that, I forgot? Is this what I can do? Neighbors. No. It's t map dot neighbors. There. Dada's neighbors are only mama, right? So it wasn't like you could go straight from A to dada. I don't know. If it, well, at least it doesn't throw an error. Let's call it a win. I'm going to work on this. I don't want to take your time up with me staring, and thinking out loud. Although I do that a lot on this podcast. All right. This is just the beginning of, and hopefully it'll just be a two-parter for PriorityQueue, because we're running out of time and it's a high priority. All notes will be in the PDF notes or the podcast feed or whatever, wherever. It's, retraice.com, retraice.com. This has been segment number 91, coming to an end this year, 2022. And this is the second, it's December 22nd, December's at 12. I guess that messes up our palindrome a little bit. All right, same time tomorrow, 10 p.m. Eastern. Probably not a doubleheader. 7 p.m. Pacific. Signing off.